Now, two very important formulas in dispersion are what you call your variance and your standard deviation. As I've mentioned, these two measures really illustrate the level of spread or the distance of all the data from the center point, which is your mean, right? So this is a good way to illustrate, for example, in this case wherein you have the same mean for both populations, or sorry, for both samples, like in CEC and CECB, we have the same mean, which is 26. Which group, okay, of measurements is more farther apart from the mean and when you look at it? So we use two formulas. The first one is what we call variance, and the second one is your standard deviation. So in computing for variance, we use this notation or this formula. So variance is also denoted as S squared. So in computing for your variance, you multiply the number of observations by the summation of the squared observations, and then you subtract that from the square of the summation of observations. So these two, don't be confused by these two. These are different. This is the summation of the squared observations. Okay? And this is the summation of the observations. When you get the summation of all this, this is when you will square it. Okay? All over the number of observations times the difference between the number of observations minus 1. Right? So, I've expanded the tables here for CEC and CECB. So remember that all of these observations are your excess, right, of the 12 months of observing the number of customers in the CEC. So if you get the total or summation of all these observations, you will get 312. So this is your summation of X. So you will place it here, right? And what we also need is the summation of the squared observations, which means that for the observations that you get here, the ordered observations, you will just get the square of that. So for example, the square of 10 is 100, the square of 15 is 225, and then etc. And when you get the square of all the observations, you will get the total or summation. So the summation of X squared in this case is 9,152. So plotting that in this formula, so for example for CECA, alright, so what is the variance of CECA? So using this formula, that's 12 times 9,152, summation of X squared, minus summation of X, which is 312, and then you square that. Alright? So, and then over 12, which is the number of observations, times 12 minus 1. So if you compute all that, the result would be that for CECA, the variance is 94.5454. Okay? And if you get the variance, it's already very easy to get your standard deviation from any scientific calculator. This is the formula for standard deviation. Okay? The standard deviation, or S, is simply the square root of your variance. Okay, so for example, this is your variance, you just get the square root of that to get your standard deviation. So for CECA, the standard deviation is 9.7234. So what does this mean? Alright? Okay, that although for CECA you have a mean of 26, a mean monthly number of customers of 26 in 1 year, okay, but the level of spread of the different observations is that the mean here is that there's a plus minus on both sides. The mean is 26, but there's a standard deviation of 9.7234 customers, okay, in the different months. So for example, that's going to be 26 plus or minus 9.7234 customers. That's the standard deviation for CECA. And I've also made the same computations for CECB. Okay, doing the same square of the excess. So for the case of CECB, the variance is 118.5454 and the standard deviation is 10.8878. So if you notice, the standard deviation of CECB is a bit larger than that of the standard deviation of CECA. So from this we can say that the number of customers in the different months of the year in CECB is more varied or is more spread out compared to the monthly number of customers in CECA. So although they have the same mean, okay, the standard deviation or the level of dispersion of the number of monthly customers in CECB is greater than that of CECA, right? And we'll get to the 3 standard deviation rule in a bit.